Hi Algebra students, it's Miss Carol again, and we are now working on Algebra 1B, Project 1, Lesson 4, and this is kind of a fun section because we are going to be combining linear equations and quadratic equations and finding a solution to the system of equations created by the two. So let's just jump right in. The height of a basketball player's shot is given by the equation y equals negative 16x squared plus 20x plus 6, and that's what we calculated in lesson 3. A defender is trying to block the ball and jumps at the same time the ball is released. The height of his arms as he jumps is given by the equation y equals 7x plus 3, which you can tell because the exponent on the x value is just 1. This is a linear equation. Use your knowledge of quadratic and linear equations to determine how many seconds pass before the ball and the defender's arms are at the same height. Okay, so question 1, we're going to look at this graph here. And the situation can be represented by that system of equations, y equals negative 16x squared plus 20x plus 6, where that is the height of the ball. Okay, let me go ahead and write that there just so we're super clear. This is the ball, and y equals 7x plus 3, where this is the hands or arms. Okay, so you can see that we've got our line here and our parabola here. The solution to a system of equations, if you'll remember from Algebra 1A, when we were just doing solutions to linear equations, those solutions were where the graphs cross. This is the same. The solution to a system of equations, even if you're dealing with a quadratic and a linear equation, is going to be where the two graphs cross. Okay, so they cross here at what looks like t equal 1 and h equal 10, and then over here at about t equal negative 0.2 and a little bit less, and h equal less than 2. Okay, so those are the 2 points that it looks like they cross. Okay, so next question. What we just looked at in question 1 was solving the system of equations graphically. And now we can solve it algebraically as well, and this will give us a much more precise answer. I mean, we can look at a graph online and come up with a really precise answer, but we can also do it algebraically. And so if we want to know the 2 points where these lines cross, or the 2 points at which their pairs, their coordinate pairs are equal to each other, then we have to set those two equations equal to each other. So that is going to look like this. Negative 16x squared plus 20x plus 6 equals 7x plus 3. Okay, so that's a first step, but we can't solve this until we put it into standard form. And if you'll remember, standard form is ax squared plus bx plus c equals 0. All right, so all I have to do is get a 0 right there on the left side. And in order to do that, I'm going to subtract 3 from both sides, and I'm going to subtract 7x from both sides. And when I do that, I get 16x squared plus 13x plus 3. So 20x minus 7x is 13x. 6 minus 3 is 3 equals 0. Okay, so this is what we're going to use to find the 2 points, okay, the 2 sets of ordered pairs where the graphs meet. All right, so now we're being tasked with using the quadratic formula to solve that. So I'm going to write it up here so that we have it. Minus, well, let's say, why do I keep doing that? Minus 16x squared plus 13x plus 3 equals 0. And then remember, standard form is ax squared plus bx plus c equals 0. So we are in standard form. So a equals negative 16, b equals 13, c equals 3. And then our quadratic formula, minus b plus or minus the square root of b squared minus 4ac all over 2a, and those will be equal to our two values of x. Okay, so I'm going to start plugging things in. I'm going to plug 13 in for b. I'm going to plug negative 16 in for a and 3 in for c. So negative 13, because my b value was positive, plus or minus the square root of, let's see, I know that 13 squared is 169, minus 4 times negative 16 times 3. Okay, and then that's all going to be over 2 times a negative 16. I'm going to simplify this a bit. I get negative 13 plus or minus the square root. Negative 4 times negative 16 times 3 is 192, so I'm going to add those because I have two negative values, so they become positive. So 361 over 2 times a negative 16 is negative 32. I'll simplify this one more time because the square root of 361 is 19. So I get negative 13 plus or minus 19 over negative 32. Okay, so one x value will be when I add 19 and the other will be when I subtract. So x equals negative 13 plus 19 over negative 32. And when I do that on my calculator, I get a negative 0.19. Okay. The other x value will be at negative 13 minus 19 over negative 32. Negative 13 minus 19 is a negative 32. So negative 32 divided by negative 32 is a positive 1. Okay, so those are the two values of x where it crosses the parabola. All right, so let's see where the line crosses the parabola. Let's just make sure that that is indeed true. Go back up here, and sure enough, x of just less than 0.2 is where point C is, and an x of 1 is where point E is. Okay. The next question is going to ask us to solve for the y values of point E and point C. So hopefully we'll end up with something a little less than 2 for this one and 10 for the 1 value. Okay. So we're going to take those values of 0.19 and 1, and we're going to plug them into either of our original equations. And I'm going to suggest that we plug them in to the easy one. I'm going to suggest that we plug them into 7x plus 3. So that's how we're going to get our height. We're not going to plug it into the 16x squared plus 13x plus 3 because that was just to come up with the solutions. To get the actual heights now, we need to plug it into either of our original equations, and both of them should give us identical answers at those points because that's where they are equal to each other. All right, so I'm going to say, we're going to do it for the easy one. We're going to say y equals 7x plus 3. And let's plug in 0.19 for x. And it's a negative 0.19 plus 3. And y equals 7 times 1 plus 3. This one's easy. 7 times 1 plus 3 is 10. But for the other one, I do need to use my calculator. And 7 times 0.19 negative is a negative 1.33, and then add 3, I get a positive 1.67. Okay, so those are very close to the numbers we were looking at. We were looking for something just under 2 based on our graph, and we were looking for a positive 10. So you can go ahead and write those in there. Okay. And then think about the context of the problem and what the variable represents. Which of the two solutions is viable? Okay, I'm just going to pop over to this graph here. If we're looking at, this is the same graph and it's just skewed a little bit tighter along the x-axis. If this solution here is at a negative t, a negative time, so when the ball is at 1.67 feet, that's at a negative 0.19 seconds. I wish we could travel back in time, but that is not a viable solution. So the only viable solution here is at 1 second and a height of 10 because it's a positive time. All right, so that's all you need to write for number 5. The only viable solution is where we have a positive x coordinate because we can't travel backward in time. Okay, let's keep going. Last question. So what is the height in feet when the ball and the defender's arm are at the same height? I think we've established that the only viable solution was at t equal 1 second, which gave us a height of 10. So that's the height that it works, that they work together. Okay, so I think the tricky part on this was realizing that when you were calculating, after you'd come up with your solutions for your values of x, that negative 0.19 and 1, then you had to plug those back into one of the original equations in order to get the height. You couldn't plug it back into your new equation where you'd set the two equal to each other. That wouldn't give you the height. You have to go set it back into one of the original equations. Okay, so you've got one more lesson in Project 1, and then you'll submit, and I will be back here for Lesson 5 shortly. Thank you.